Alright, so I think I'm recording. Let's take a look at our review problems for the semester review. I've just went ahead and cut and pasted the answer key for the complex numbers. Now, our skill packet was labeled 6. This was a different order. I think that we can use this to clarify any problems that you might have. Here, we're just adding we're adding the first two complex numbers together and then subtracting the last one. It's just combining like terms. So we've got 6 plus a 5, which is 11, minus 9, which is 2. And then we've got, so we're just treating these like terms. Negative 4i, negative 1i, minus 5i, minus 10i is what you should get there. When you're multiplying binomials together, you can either form a table or a FOIL or however you like. I have, if I distribute the 5 through both of those, I've got 5 minus 15i. If I distribute the 2 through both terms, I've got 2i minus 6i squared. Now, we do have to remember that I squared is negative 1, so this is take the negative and the negative makes that a positive 6, so I've got 11 minus 13i because negative 15i and 12i. So however you choose to multiply binomials, whether it's in a table, whether it's writing FOIL, whether it's some other organized method of applying the distributive property, just make sure that you get 11 minus 13i. Now on the next one, we can cut a little bit of corners if we recognize that 7 plus 2i and 7 minus 2i are complex conjugates. And if I multiply a plus bi times a minus, that's a terrible a minus bi, I know that the formula is a squared plus b squared. So there is no I. So when I multiply complex conjugates together, I'm going to get a real number. And here all I had to do is recognize that a was 7, so I have 7 squared, that b is 2, 2 squared, 49 plus 4 is 53, and I'm done. Alright, now here, when you're squaring something, the exponents do not distribute, so treat it like you did in problem number 2. 6 times 6 is 36, 6 times 5, 30i, and then you have then you got 5i times 6, and 5i times itself, and 36 minus 25 is 11, and 30i plus 30i is 60i. So just do not distribute the 2 through. Now, remember that the formula for a complex conjugate, a plus bi times a minus bi, is a squared plus b squared. Now, the formula for taking the absolute value of a complex number, the absolute value of a plus bi, I'm afraid that some people have confused the a squared plus b squared with the square root of a squared plus b squared. When you're finding the distance, when you're finding the absolute value, it has to be the square root of a squared plus b squared. So identify a and b. So we've got 7 squared plus 2 squared, 49 plus 4, that's 53, but remember it's the square root of 53. 53 is a prime number, and I can't simplify that any further. Now, when we have division, this is the most difficult one, simply because it's the longest one of the bunch. You've got 5 minus I over 2 plus 3i. It is against the rules to have the imaginary unit in the denominator to do this division. It's a common technique in algebra. We're going to take this fraction, we're going to multiply it by the number 1. When you multiply by 1, you don't change the value of it, but I'm going to be clever in how I multiply by the number 1. I'm going to take the conjugate of the denominator. 2 minus 3i is the conjugate, the complex conjugate of 2 plus 3i. So I know that when I multiply these denominators together, I'm not going to have an I. I'm going to have a squared plus b squared. I'm going to have 2 squared plus 3 squared, 13. Now, when I multiply the numerators together, I'm going to have to use the distributive property and treat it just like I did previously with a binomial times a binomial. So 5 times 2 is 10. Then I've got minus 15i minus 2i plus 3i squared. But I squared is negative 1. So 10 minus 3 is 7 minus 17i all divided by 4 plus 9, which is 13. Now, technically, that's not in A plus BI form, although I accepted that answer on your test. There may be a day where someone doesn't accept it, and A is you take the single fraction, you make two fractions out of it. Everybody gets divided by 13. So I've got 7 over 13. I've got negative 17 over 13 because they want A plus BI, where B is negative 17 over 13 and I is the imaginary unit. So that's how I'm getting my answer for 6, but you can leave your answer like that. I don't care about that. Now, some of these problems are multiple choice problems, however, and maybe you might have to recognize your answer as in this A plus BI form, come to think of it. All right, so I hope that helps on this 1 through 6. Talk to you later.